Hello! In this video, we are going to work on graphing exponential functions. So I am starting with this sheet. That way it kind of organizes what we're going to be doing. We are just going to start with the basics right now, and then we're going to work on the other parts of the equation. So this video is kind of two parts. First, we're just going to look at what we refer to as the parent graphs of exponential functions. All right, so to start off, the equation that we are going to graph is y equals 2 to the x. And that is a parent graph. And we call it a parent graph because there's nothing else in this equation except for 2 to the x. So this is just the main plain graph of 2 to the x. All right, hopefully you remember how a t-table works over here. So this is what is going in place of the x. So if we fill in the x with 2, that means that we have 2 squared, and 2 squared equals 4. So that right there is our first ordered pair. So we have 2, 4. All right, now we're going to fill in x with 1. So if we fill in 1, we have 2 to the first, which equals 2. So that ordered pair is 1, 2. If we fill in 0 for x, we get 2 to the 0, which hopefully you remember and understand that that is always going to be 1. So we have the ordered pair 0, 1. If we fill in negative 1 in place of x, that's 2 to the negative first. That is 1/2. So the ordered pair is negative 1, 1/2. And then if we fill in negative 2 in place of the x, that's 2 to the negative second, which is 1/4. So negative 2, 1/4. So now I'm just going to take these ordered pairs and plot them on the graph. So 2, 4, 1, 2, 0, 1, negative 1 is 1/2. So I'm just estimating halfway. Negative 2, 1/4. That's just a little bit right there. So this gives us the basic curve, which is what happens when we graph an exponential function. We get a curve, an exponential curve. So what's happening here is that since the equation is 2 to the x, all we're doing is multiplying by 2. So this is at 4, the next one would be up at 8, the next one would be up at 16, the next one would be at 32, and so on. So this over here is just continuing to get steeper and steeper pretty quickly because we're doubling the previous y value every time. Now what's happening over here is this is going to continue to get smaller and smaller, but it's not actually ever going to reach 0. So it's going to get so close we're not going to be able to tell, but on our graph, it's just going to look like it's going to run right alongside. Excuse me. All right, so this is the basic curve of 2 to the x. There is a special part of this graph similar to the axis of symmetry on a parabola. So this is your opportunity to almost say a bad word in math. We have an imaginary line right here, and it is preventing this exponential curve from actually hitting 0. So if you think about it, this is coming down and then it's bending. I kind of think of it as a force field. It is called an asymptote. 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 So it's like asymptote. Asymptote. And that is this imaginary line. Again, I kind of think of it as a force field. So if you're like a Star Wars or even a Hunger Games person, you understand that this is imaginary. We can't see it. That's why we're using a dotted line. But it is a force field. So this curve, this exponential curve is not going to be able to cross over that asymptote. Now, the asymptote is similar to the axis of symmetry of a parabola, but it's different because it's horizontal. So this asymptote is located at y equals 0. And that's just because it's happening right here. You can have an asymptote that might be up here, in which case it would be y equals 5. All right, so that's the basic curve of 2 to the x. Our next one, we're going to do the basic curve of 3 to the x. So I'm going to go through similar t-table here, except this time it's 3 to the x. All right, so I'm going to replace x with a 2, so that means 3 squared is 9. I'm going to replace the x with a 1, so 3 to the first is 3. I'm replacing x with a 0, so 3 to the 0 power is 1. 3 to the negative first would be 1/3, and 3 to the negative second would be 1/9. All right, so now I'm going to come over here and plot these points. All right, once again, I get a curve that is getting very, very close to 0, but not actually ever touching it. And then it's increasing this way dramatically because each additional point is 3 times the previous y value. So my first one is at 0, 1, then I go to 1, 3, then I go to 2, 9. The next one would be 3, 27. So it's actually a little bit steeper than the 2 to the x, which makes sense because this one is being multiplied by 3 each time. This one is being multiplied by 2 each time. Again, we have that asymptote, which is the force field. And again, this one is occurring at y equals 0. And it's y equals because it's horizontal. All right, next one. Same idea here, except this time we're going to do the parent graph of 1/2 to the x. So I'm going to go through. Here we go. All right, 1/2 squared is going to be 1/4 because I'm multiplying 1/2 times 1/2. All right, 1/2 to the first is 1/2. 1/2 to the 0 power is still 1. 1/2 to the negative first is going to become 2. And 1/2 to the negative second is 4. So this is backwards, which makes sense when we graph. So this time we are doing something like this. So this one is very similar to our first graph, except each time we're multiplying by 2. On this one, each time we're multiplying by 1/2. So this one is going the opposite way of, oh gosh, look at that. That was horrible. I really should have just come down like this. I think I'm better drawing this direction. So what's happening this time is that we're multiplying by 1/2. So we have 16, and then half of that is 8, and then half of that is 4, half of that is 2, half of that is 1, half of that's 1/2, half of that is 1/4, half of that is 1/8, and so on and so on. So you may have already learned about half-life in science, so that's what this one is right here. All right, once again, we have that asymptote, which is the imaginary force field. That's why we're going to use a dashed line to graph it. And this one, again, is located at the x-axis, which is y equals 0. All right, so the next thing that we're going to do is go to notebook paper, and we're going to talk about how these graphs are going to help us to actually do a graph that has additional other numbers in the equation. So I'm going to switch over, to some notebook paper here. And I'm just going to write it out. Let me turn around here. I'm going to kind of write out pretty large in the middle, and then I'm going to show you what's happening here. So I am going to show you the standard traditional times b x minus h plus k. All right, you might recognize some of this from our unit on quadratics. And I had mentioned that there's a lot of similarities here. And this is why this unit isn't going to be quite as tough, because we've already been exposed to a lot of this stuff. So let's think about what happened when we had an quadratic equation in vertex form. So it's very similar to that. All right, so first thing that happens, if you remember, if our original leading coefficient up here is a negative, that caused a reflection over the x-axis. So that still happens. So if our leading coefficient is negative, it's going to be reflected over the x-axis. Okay? The a value, if you remember in our quadratics, this was the stretch or shrink. So, stretch or shrink. Now, the question is, do you remember when this caused a stretch and when it caused a shrink? Well, it's going to be a stretch if a is bigger than 1, and it's going to be a shrink if a is less than 1, but still positive, because the negative causes the reflection. So if this number is bigger than 1, we're going to stretch. If this number is smaller than 1, but still positive, it's going to be a shrink. So that's where we said, oh, this parabola is 2 times taller, or this parabola was half as tall. Same idea on our exponential. All right, this right here, this b, this is our base number. So this is our parent graph, if you want to think of that. This right here, this b to the x, this is what's going to be in every single problem here. So this is our starting right here. So we're always going to have this in every equation if it's exponential. Okay? So that's our base, our parent graph. So these that we were just doing, the 2 to the x, the 3 to the x, the 1/2 to the x, that's what's going to be right there. All right. Now, next up, let's look at how this affects our graph. So when we were doing parabolas, that minus h, this hk was our vertex, but this was the x value. And if you remember, that means it's going to go right or left, but it was always the opposite. So this is going to shift our curve right or left. But if you remember, it's going to go right if it's a minus, and it's going to go left if it is a plus. Okay, so, and again, remember that we're having to solve this one because these two are on the same side of the equal sign. These two are on opposite sides of the equal sign, so we don't have to worry about this But this, we have to move this h over to the other side of the equal sign, which is why it's the opposite. All right, and then the last one is this plus k. And if you remember from our parabolas, hk was the vertex. The k is the movement along the y. So this is going to shift up or down. And it's up if it's positive and down if it's negative. And again, those are on the opposite side. So if the y is 3, it's actually up 3. So we don't have to move anything over for that. Okay, so this is what's going to happen with graphing. So just for an example, we'll do right under here, example 1. Let's say I gave you this times 3 to the x plus 4 minus 5. All right, so let's say we had this equation right here. Well, first off, we're just going to describe the transformations that are happening. So what we're doing is we are starting with the 3 to the x curve. So we would be using this curve right here, okay? And then what's happening to this curve? Well, let's start at the beginning and work through. This is 1/2, which means that it's going to shrink. So we're going to shrink to half the height. Okay. This plus 4 up here is going to go right or left. Since it's a plus 4, it's going to go left. So we're going to shift left 4. And then this right here is our k, and since it's negative, we're going to go down. So we're going to shift left 4, and then we're going to shift down 5. So when we start graphing, which we're getting to eventually, what we do is we would take the 3 to the x curve, which is this one right here. We would shrink all of these points to be half the height. So we're going to shrink this down to be half. That's going to be half, half. So we're going to shrink all this down to be half the height. And then we're going to shift this whole curve left 4 and down 5. So we're going to take these points, shrink them, and then go left 4, down 5. So that's where we're getting to. But today we're just going to practice on what is happening with all of the numbers in the equation.